take a look at the vectors, vector addition lab actually, since most of you now should be much comfortable with adding vectors. That's what we're going to do. When it comes to vector addition, I think we discussed this many times during the class. We divide that into two categories. One is graphical method. Graphical method means I can make a graph in a graph sheet, and then I can do measurement like physically, real measurement with the meter ruler and protractor to identify the magnitude of the vector and the direction, right? So that's a graphical method that has a two different way to do that. So the one is I can do by using the triangular method. Triangular means after I draw the diagram, I will end up triangle. Okay, that's the idea. So the other one is in the parallelogram. Parallelogram means after I draw the diagram, I'm going to end up as a parallelogram. That's very simple, two technique, but we're not going to use either for the regular in-class question and then so on, because it's going to be a lot of time consuming. Not much useful either, because it's too time consuming process, and then going to work with either few vectors. Like for example, parallelogram method can be done with only two given vectors at the time. You can repeat it again and again for many vector situation, but I can use only two vectors at a time. This can be done actually with any vectors at the time, but it's very time consuming. Okay, so we're going to take a look those two very in detail. That actually major part of this class if you're doing this lab, if you're doing in-person setting. So all you're going to do first hour or so making those diagrams and then doing the measurements. And then the analytical method, we already did many times in the class. So the divide into two, we're going to be talking about cosine and sine rule method. Not much useful because that can apply again for two vector situation. If I have a many vectors, I have to go each two vector at a time. Okay. So that's not much meaningful, but we can take a look that little bit in detail. The last method is the most important one, component or projection method. So that's the one we actually used during the class so far, last two chapters particularly. We've been using vector component and the vector projections, okay? So we're going to take a look at that also. So then at the end of the calculation, we're going to compare each of these, one of this method to one of this method, analytical method, in terms of answer wise, whether we're getting the same answers or not. Or we can compare actually these two methods, analytical two methods, to see whether I'm getting the same answer or not. That's the plan. Any question? Okay, then let's take a look how to do the vector addition by using graphical method. First, we'll do the triangular method. Usually what we do, we're gonna take the graph sheet. Graph sheet has a centimeter and then millimeter scale, right? Let's say, for example, I want to draw vector here. Let's take an example from our table. So let's go into the given two example right here. So the case one, it asking me to add these two vectors, right? So the vector 1, 8.6 Newton, angle 35.5, vector 2, 11.7 Newton, angle 160. Now, if I want to draw these vectors, I can't draw Newton, so which means I have to have a unit conversion. So I can assume maybe 1.0 Newton is equal 1.0 centimeters. Each centimeter line I draw represent 1 Newton, which means if I want to draw 8.6 Newton vector, I can draw that as a 8.6 centimeter line. And then if I have the proper angle measured on line relative to the positive x-axis, that's going to be the direction of that vector theta 1. So now how we draw this, usually we need the coordinate system. First you draw vertical line and the horizontal line. Usually we try to keep the 0, 0 somewhere in the middle of the page. Then I have freedom to go all 4 quadrants as needed, x-axis and then y-axis. And then we can draw the first line, first vector. So first we're going to put the protractor here if it is a real in-person classwork. Then we're going to identify the 35.5 direction. Then we get rid of the protractor and then draw a small dotted line. That is the direction of 35.5 relative to positive x. Then we take the meter ruler, measure the length on this line starting from the origin on this line 8.6 centimeters. That is going to be vector F1. Then we're going to make that line solid and then put arrowhead. That arrow is actually represent the direction. Size of that line represent the F1, which means this angle should be θ1. That's how we drew in that part. Going to take a little bit of time if you're doing in person because that drawing need to be done very precisely. Otherwise, human error going to be always added up. Okay. Then on top of that, we're going to do tail to head method first, or the triangle method, which means after I complete the vector diagram, I should end up with the triangle, right? That's the meaning of the triangle method. So to do that, what we're going to do, end of this first vector, we're going to draw a horizontal line right here. We don't need to draw actually. If it is a graph sheet, you have those lines. We're going to see those lines easily. So we're going to put the protractor here. Align the 0, 0 point exactly to the end of the first vector. Then we're going to measure 160-degree angle. That should go towards the second quadrant, right? That dotted line blank. And then we can draw 11.7 centimeters on this line. So you can make it solid, put arrowhead. Usually we have a lot of color pencils. We can use different colors when you're drawing that. And that is our second vector, F2. And the angle, this angle right here is 160. Now, result of these two vectors, like for example, if somebody started from here, let's say point A, he go to point B, he go to point C. Now the displacement of that person means the closest separation is straight separation between the initial point and the final point. That's what the displacement means, okay? It doesn't matter how he went to the final location. He could go left, he could go right, he could come back and then do many things. Like you're coming from the home to the campus, you can take a turn, you can stop by a shop, stop by a gas station, do whatever it is. But finally what we're interested in is the displacement between the home and the campus. So when we measuring that, we don't care how you went. What we care is straight separation between the 2 points. So that means between A and C, that line is this one. That is we generally call the displacement. Now that actually our resultant R of vector 1 and 2. You can see after you complete the diagram, you should see a triangle. That's why it's generally called the triangular method. However, that term is not going to be always meaningful. The reason, if I have more than 2 vectors, I'm not going to be ending up triangle. I'm going to end up some sort of different polygon. Okay. That's it. Then what we do, we take the meter ruler, measure the size of this line in centimeters. Let's say size is R in centimeters. I know each 1 centimeter is 1 Newton, which means the size R, I can put the unit Newton here because unit centimeter actually equal to the unit Newton in real case. So that's the magnitude, right? So the magnitude of the vector R12. Then we need to find it out the direction because you can't tell the vector by just only magnitude. You have to always tell the direction too. Direction, I can measure this angle right here, starting from the positive x to the line of AC by using the protractor. So that will be actually our theta. So very, very simple method, but the problem is it time consuming and also the accuracy wise. You can have a lot of errors if we usually do like 4-member, 4-student group or 3-student group. Every student in the group doing this drawing alone individually, but everybody getting slightly different answers. Let's say this line right here. Let's say, for example, one person measuring it 9.81 centimeters. Then the other person not going to get exactly same. He going to get a different number slightly. Like maybe he will get 9.80. Someone else get 9.82 and then so on. And the angle also same because there's observational error always attached in such measurement. Okay. Question? Okay, with the simulator, it's more simpler. That's why we're going to do a lot of actually analysis method. The second one, the analytical method, two method in detail because simulator actually makes the first part very simple and easy. So there's a link right here on page number 4, very top, PHET. If you click on that link, it will open up the simulator. Okay, so the going forward from next week and then beyond, always we're going to use a simulator to collect the data. That's what exactly we're going to do from today. Okay, like we done on the last experiment too. We got the data and then the analysis part we done with the Excel. That is the same process going forward in every single lab. Okay. There's 4 options. The best one is the option number 3, says lab. Just double click on. This should work without any problem in any web browser. There's nothing to worry about. But if it's not working, just let me know. I think if it is not working most of the time, problem with the your web browser, you can try maybe with a different web browser or something. Otherwise, it should work without any trouble. Okay, guys, question, problems? Okay, then this is a graph sheet. I have XY line. So let's move this origin to the mid. You can do that by bringing the cursor on top of the crossing point right here. Then you can see the cursor is changed like into a cross sign. And then you can click and drag. Make sure you do that because I need the space in the first quadrant and the second quadrant very much because I have one vector on the first, second vector on the second quadrant direction. So my resultant gonna be on the second quadrant, okay? So we need this space right here on the top a little bit more. And we can maybe leave it like that, little bit more space to the top part of the page. And then left and right like equally divided also. And this look like a regular graph sheet, like a larger squares, like a centimeter square, and smaller squares like a millimeter. But however, it's not exactly gonna fit with the millimeter because each large square divided into only 5 small square instead of 10. So we can't really exactly do that kind of conversion. Technically, there's no units attached to this page at all. We can put the unit ourselves. Okay, so it will show us the numbers. We can put the unit accordingly. All right, guys. Any question? Okay, then we'll start drawing the vectors. Vector can be drawn by clicking and dragging any of these lines. Please use the yellow line first. Do not mix the two lines together, two colors together, because if I use many blue lines, don't mix the blue and yellow. Okay. If you're using blue, all vectors should be in blue. The reason, if I use 2 or 3 blue vectors, the addition of those vector result and I can get by just clicking this sum on the very top right hand side. Okay, so we'll draw the first vector. Usually I should draw starting from the origin and then adjust the direction. It's difficult to see any numbers here clearly, right? But if you click the values on right hand side very top, that will show you the magnitude of the arrow. If you click the angle just below that, right hand side top, then you will see the angle relative to positive x. Okay. Then you can't actually put anywhere this arrowhead. You can see if I click the arrowhead and then I can drag, but arrowhead go only the places where the two lines are crossing each other. Okay. So I don't have freedom like I'm really drawing in a paper. So I have to pick the numbers accordingly what is possible in the simulator. Okay. So the numbers given in the table already tested, which means I should be able to find 8.6 and 35.5, but you have to do a little bit of adjustment, which means technically you have to click the arrowhead and then move around a little bit somewhere around first positive score line and then first positive score line to the x and then y both. That's the coordinate. And then if you move around by looking at these two numbers, you can find exactly 8.6 and 35.5. Okay. Question? All right, so that's our first vector. Then we'll draw the second vector starting from top of that. End of the first vector is the starting point of the second vector. Then we'll click the arrowhead and then drag towards the second quadrant direction. And then check the angle 160 and the magnitude 11.7. If you go the coordinate wise, -1 on x, +2 on y, around there, just move the arrowhead, then you can find exact location. 160 angle starting from +x, 11.7. And then that's it. Then I have my vector diagram, because we are adding only two vectors. So if you click this sum right here, that will now show you the resultant, which means you can see now that arrow, magnitude 9.8, angle 114. To make sure that's the real resultant, I should click and drag and then put it right here. Then it will close the gap, very starting point to the very end point of my vector diagram. In that dark blue line is the result. So magnitude is 9.8, angle is measuring from +x is 114. That's it, that is that simple. Okay guys, question. Okay, then we'll write it down, that information. Make sure you need to add the unit also. R is measured in unit Newton. You can get rid of the equal sign with the R and then put the unit Newton inside the square brackets. And the angle theta must be measured in unit degrees. Unit degree sign, you have to find insert symbols, click the symbols again. Then you can find the degree sign. Maybe you need to take a look, fonts, symbols again, okay? Click down arrow on the fonts and then select the symbols, then you should be able to find that. So that degree sign should be included here, okay? All right. So all of the rest should be the same. I'm gonna just copy paste this R and theta, a little bit easier then. And the theta with the degree sign. Okay, any question? Okay, let's then record the resultant. I'm getting 9.8. You can record only the numbers visible, okay, because this is observation. I cannot add any extra decimal places or anything, okay. 9.8. It's not as accurate as the given number. That's okay, because that's what we can directly measure. And the angle theta 114.0, that I can measure all the way down to the first decimal place. It's 4 sig figs. which means this one I should add one more sig fig. You know how to manipulate the significant figures. Click on any shell, home menu bar, middle top, number area, and then there's a two small arrows, right and left. If you click the left arrow once, it will add zeros extra. Okay, question. All right, then we'll do the same triangular method, but we'll do the case B, which means we're going to add 3. For that one, what I'm going to do, I'm going to put you guys into breakout rooms because this lab going to be a group lab report. When you're making the group lab report, since we have like around 12 or so students, I will put you guys into like four groups, like 3-member group. That will be your group members, okay? So you have to talk among each other, connect each other, and then communicate. Some student may not be willing to write a group report. That's okay. You can write this as individual report if you want to. That's totally fine. If you're making a group report, then all the group member names should be included in the front page. And then there's extra page at the end of the report explaining or detailing which group member did what. It is not enough some group member just participate in the WebEx breakout rooms. That's not enough, okay? Because you have to do the data table together. Every single person must submit the data table. Report can be submitted as a group report, one per each group. But when it goes to the group report, each member has to write a certain part of the report, which means, let's say there's 3-person A, B, C. Person A can write objective and the theory principle. Person B can complete data analysis, procedure and data analysis, and the person C can complete discussion, conclusion, and the post-lab, pre-lab correction, things like that. So those details should be included as extra page at the end, okay? If one does not contribute, then the other people can complete the report and submit without the person who are not contributing. Participating the WebEx breakout rooms is not enough, okay? That's not count to anything. That's just the place for making that group only, okay? All right, any question, guys? Okay, we'll first take the simulator picture here. In general, we need the simulator picture, a screenshot, insert a screenshot, screen clipping. In that simulator picture, you have to get everything because this whole thing is a simulator, right? Including everything. And then add that picture into here. That should go to the procedure section, okay? Then inside right here, these places are for vector diagram. So the vector diagram does not need to include these other information. That needed only that diagram we created. Okay, zoom in picture of that. We'll take a picture of the vector diagram, and then for the case 1, we'll insert that. We'll take only this part. That is actually part of a data that should not go to the procedure section. That should stay in the data section. Okay. So just under the table, when you copy paste the table into your Word file, you have to copy paste with this pictures just under table 1. Okay. All right, guys. Question. What is your question again? How to get the screenshot? Okay. All right. Any other question? Okay. So that Very simple. So this diagram is actually our part of the data. Okay, that's why we need that under the table. Now, you guys can do in your breakout rooms the case B, this triangle method. Okay, remember when you're doing the case B, let me give you like some input to the case B. When you do in case B, I have three vectors, right? So there's two ways to do the triangular method. One is without considering triangle, I can just draw a vector diagram by considering tail to head method, which means we're gonna start from the coordinate 0 point and then draw the first vector. You know that's f1, theta 1. And then end of that, we're going to draw the second vector. Those two actually already there in the diagram. This is theta 2, this is going to be f2. Then from here, end of the second vector, I can draw the third one. If you look at the third one, that is actually toward 234-degree direction. 234-degree direction, 13.6. Now starting from here, 234 gonna be in this word direction, right? Somewhere to the third quadrant. This total angle should be 234. And then this will be the vector f3. Now the problem when you measure in this angle, particularly theta 3, our simulator actually does not allow you to measure anything more than 180. Like in the regular protractor can measure only 180, right? You cannot go above that. Because of that, what we can do in the simulator, how it's showing you the angle, always if you go above 180, a angle look like this, it actually gonna use the angle only this part, which means instead of giving the positive angle here, it will show you the negative angle. You have to be careful, okay? Which means theta 3, if I want to get that in negative, what you have to do, take the theta 3 minus 360. Get rid of 360, then you will see an answer. That answer is actually equal to the negative theta 3. Theta 3 angle, but negative direction. Okay, you remember that rotational direction have that answer for that y positive and negative. In vector chapter number 2, we discussed that very in detail. If rotational is counterclockwise, then we say it's a positive rotation, positive angle. If rotation is clockwise, we say negative rotation, negative angle, okay? All right, that you have to be careful when you measure in the third vector. Then your resultant should be this guy. Now, this is our vector diagram. You can see triangular term no longer meaningful. That's why we generally call it tail to head. Then the result is actually this line right here. You need to find that, okay? So let's take like maybe, I mean, you can do it like within a minute time. I just need 1 minute to do that. But let's take like few minutes on your breakout rooms and then I will bring you back after maybe 5-6 minutes so you can connect with the peers, talk to the peers, and then make sure you're going to go back into the same breakout rooms again at least 1 or 2 hours. That will be your group, okay? All right, guys. Any question? Mm, you have any question? You can't find the simulated, this one? That's on your lab manual, page number 4, very top, right here. It says phet.colorado.edu. That's the simulator link. Okay, so let's take few times in the group setting and then try to complete that. Complete the table too, okay? Take the picture, put it into the place, and then complete the table. Okay. So I had the two vectors initially, right? So I keep those two vectors as it is, first vector and second vector. Then end of that, I draw the third vector, which is 234-degree positive. But actually the simulator does not show you that. It's showing you the negative angle. To find it out, you subtract 360. When theta 3 is actually negative 126. So I draw that vector end of the second one. Then you click on the sum, then that will show you the resultant, okay? Then take a picture and then place it right here under the table, and then information should fill up here, okay? 12.2 in magnitude resultant, and the angle of this one, again, you can see it shows the negative angle, which is not we usually report. We usually report the positive angle. To get that, you can add 360 into 170.5, which is the negative angle. Then it will give you 189.5 positive angle. Okay, that's the number we need. Yeah. Okay, guys, any question?
Professor, isn't your screenshot in the wrong box?
No, yeah, this should go in here. That's good. Yes.
All right, thank you.
Yeah, that should go into case B, case B part 1. Okay, yeah, that's correct. Okay, guys, any other question? Okay, then we'll do the parallelogram. Its only difference is actually parallelogram automatically include the triangle. Only problem with the parallelogram, I cannot do parallelogram method for more than two vectors. I can do only at a time two vector situation. Okay, that's the only difficulty. Otherwise, it's not anything challenge at all. So how we do that? At the end, we have to have a parallelogram after we draw, right? So first we start with the coordinate system. We'll draw the coordinate system. We'll draw the first vector starting from the origin, like we done for the previous method. That's going to be f1, theta 1. Then in the parallelogram method, we're going to have only two vectors. Both vectors must start from the origin. Should not start one after the other, okay? So the second vector, which means should start from here. So it is on the second quadrant, F2. This total angle is actually theta 2. Now we'll make a parallelogram. How to make the parallelogram? You have to make the parallel line to this green line at the end of the vector number 1. So there should be a line passed through here. That dotted line, that green dotted line, should be parallel to this vector. These two lines, the green two lines, should be parallel to each other. Then draw another parallel line which pass through end of the vector F2. These two blue lines should be parallel to each other. Then you can see I have a parallelogram. Let's say this is ABC, this is D. Now that ABCD is a parallelogram. Now the resultant vector is actually the vector which is line which is connecting these two places A and D, very beginning point to the crossing point of the two other lines, parallel lines. So that is actually the diagonal. So the magnitude of the AD, which is actually the magnitude of the resultant, and the direction of the AD measured relative to X, which should be the direction of the resultant vector. Now, if you look carefully, triangular method already included because AC is exactly same as BD. So technically this line is exactly the vector F2, this line right here. That's the F2. So if you look at now ABD triangle, that triangle already representing triangular method. So if you're considering only two vectors, technically the triangular method already embedded inside the parallelogram method. Okay? If you're doing this in-person class, making that parallel line little bit tricky. Not impossible, but little tricky to do that. Otherwise, it's It's a very simple technique again. Cannot be done with the more than two vectors. At a time, you can have only two vectors, okay? Okay, guys, any question? So let's get rid of the third vector. I have the two vectors, right? I just need to move this into the origin. Then I have the two vector situation. Let's make the parallel lines with the other line. There's a yellow color like the orange color line. Let's make the parallel lines with that. So I want to make the parallel line to F1. I'm gonna make sure this line is parallel to F1. Size doesn't matter. Only I need just to make sure that it's parallel, okay? Then I'm going to move that to end of here. That is a line parallel to the F1, okay? Then make another one, which I need to make sure parallel to the second vector F2. I just want to make sure that is parallel. Then I'm going to move that also end of the first line, first vector F1. Now I have a parallelogram, okay? Those orange line are extra vectors which I use. Now, if you click the result and blue, you can see result and blue now right here. If I bring that and then place exactly on the diagonal, then that should exactly fit with the diagonal. So that actually the result. Okay, that's the idea. So drawing that parallel line is little tricky if it is in-person class work. Otherwise, it's very simple thing to do. Any question? Okay, then let's take the screenshot of this part only we interested, right? That's our diagram, and that should go actually here, right? Can make it a little bit smaller to fit with the area, and then we'll write it down the results here. I'm getting 9.8 and the angle 114. There's no difference at all. The reason this is a simulated result. Okay, make sure you show enough significant figures, 4 of them for the angle, but we can observe directly, and only 2 for the magnitude. Okay, you can move this one to make sure the angle 114. All right, guys, question.
I'm sorry, Professor. Could you go over that method again
Sure.
on the simulator? Yeah.
Yeah, so what we did, let's get rid of these two lines. So you had these two vectors already there. So I moved the resultant vector, it was here earlier. I moved that away. You can even move completely off. That's totally fine. Get rid of the sum here. And then move the vector number 2 to the origin starting point. Then I have two vectors. To build the parallelogram, I need to draw two parallel lines to each vectors, right? I first identify the parallel line, then move that to the end of the second vector. Then this orange line is parallel to vector 1. Then bring another orange line, and then first identify the parallel to the vector 2, which means put it on top of the vector 2, but elongated that. Then move that at the end of the vector 1. So now I have two lines, two orange lines, which are parallel to the vectors given. Now that's our parallelogram. So then if you click the sum, a line will appear. If it is the right sum of two blue lines, that should be able to fit within this diagonal. If it is fitting the diagonal, then we are fine. If it not, then we have a problem. Okay, so we need to change this a little bit. Things should be good. Yeah. All right, guys, question.
Thank you.
Then take a picture, and then that should go into space here, and then magnitude and the angle actually the same. There's no difference at all. those are the differences. If you do in real in-person class, we will not get exact numbers from both method because there's a human error attached with those measurement, and then angle with the protractor and the magnitude of measurement with the meter ruler. So we will get slightly off values. If I get 9.8 here, I will not get 9.8 exactly with the other method. I might get 9.79, 9.81, slightly off numbers. Okay. Okay, guys, any question? Okay, then you guys can do the next part in your group setting. So when you're doing that part again, remember, now you have to make a parallelogram for three vector scenario. So you cannot make a parallelogram actually for three vector case. You can't do that because parallelogram method allows us to do only two vector at a time, right? Which means when you're making the three vector case, what you have to do, you can start with the resultant from 1 and 2. You have to make a vector which is starting with the resultant of vector 1 and 2. This is going to be R12, result from the previous two. This angle 114, that will be your first vector. Okay. Then I can add the third vector. Now you draw the third vector here, which is f of 3. And the angle, this total angle is given 234, but I cannot draw that. I cannot see that in the simulator. Simulator will show you this angle, okay? That should be negative 126. So then you have again two vector scenario. Now you can make the parallelogram. One parallel line here, which should be parallel to this. One parallel line here, which should be parallel to that. Then your resultant should be line connecting the diagonal, okay? So you have to start with the result from the previous two, not the previous two directly, because previous two, if you keep in there, then you have three vectors in the plane. I cannot make the parallelogram in such scenario. Okay. So that's all. When you're measuring again the same technique you have to use, you may need it to take a look the angle particularly, because simulator doesn't show anything larger than 180. If it is showing as a negative angle, make sure I need to correct that and then so on. Okay. All right. And we'll go back to the breakout rooms. Any question? continue on analytical method 1 for the case A. Okay, analytical method 1, case A right here. So let's calculate the R by using the cosine rule. Now you know the equation, you just need to write the function, okay? And angle A we actually figure out, which is 55.5, okay? So that also important. So let's write it down, that function right here, equal sign, everything should be inside the square root open bracket. If one is square, F1 is 8.6 to the power 2 plus F2 is square, F2 is 11.7 to the power 2 minus open brackets 2 times F1 8.6 times F2 11.6, 11.7 and then times cosine parentheses. There is a problem with the Excel. Excel can read only radians. Excel not going to identify when you put any degree values, okay? So you have to use the command radians, because if you put the degree value, that value must be converted into radians, okay? That function will do that. Radians 55.5. Close bracket, close bracket, close bracket again, close bracket for square root, hit enter. All right, guys, any question? All right, then there's too many significant figures here. Let's cut down. This is a calculated value. Keep like at least 2 or 3 decimals, not more than that, okay? That number should be fit with the answer we got earlier for case A. Method 1 and method 2, both I got 9.8 magnitude. So I'm getting exactly the same. If I rounded into the first decimal place, answer will be very good fit, okay? All right, then let's write it down, that function just below here. So this is R for, we can say, case A, analytical method 1, okay? Okay, make sure all those functions you need to include just under the table, all different type of functions, okay? All right, so that good. So it came out very good number. So let's find out the theta then, angle or the direction of that resultant R12. We realized earlier that we cannot find that angle directly because angle has to measure from positive x. But by using sine rules, we can find something only inside the vector diagram, which is inside the triangle. So I can find the angle B, then add 35.5, then I should get the right angle or the direction for the R12. So that angle B we can do by using sine inverse. Let's do that here. So let's write it down, that information a little bit here. This R, you need to add the units. I'm gonna copy paste from the previous table. All of these must reflect the unit. All the R's reflect the units, and also all the theta values reflect the unit degree. Okay, make sure you do that. Okay, any question, guys, for the cosine rule for the case A, method 1? Okay, then let's continue. Now to find the theta, you know I can't find the theta directly, but I can do it by adding theta for 1, which is 35.5 plus angle B, right? That's what we're going to do. Let's calculate on this cell angle B, which is equal when a angle calculated by using the Excel, that will be automatically the radian value. We are not like to see the radian value. We like to see the degree value, which means I have to have a degree command first. Then inside arcsine, inverse sine, if you type A and S, arcsine function will appear, arcsine. Inside that, F1 of 2, F2, which is 11.7, multiply by sine of angle A, sine radian commands inside, angle A 55.5, close bracket for sine, close bracket for radian, close bracket for sine, and then divide by r of 1, 2, which is the resultant vector we calculated here, close bracket for arcsine, close bracket for degrees, then hit enter. Make sure you cut down the decimals. We don't need that many. Just keep like 2 or 3 decimals. Okay, not more than that. Now that's not our answer. Okay, that is just the angle B. So let's write it down here. Angle B we calculated. So this is angle B for case A, method 1. All right, now to get the real direction of the theta, I have to add 35.5, right? Let's do that. Equal sign, angle B plus 35.5, we're getting 114, exactly 113.9. So the direction should be exactly 114 for case A. So you have to do those things very carefully. If not, you will not get the right. If not, you will not get the right answer. Okay, and also get rid of extra decimals. Maybe like 3 decimals. I think okay, you can keep it, but don't keep too many decimals. Okay. Any question, guys? Okay, make sure you add all of those functions here now. The same kind of functions we have to do for the next case B, same sine cosine analysis. So you don't need to write those functions because I included here. We will add the function for the second method, analytical last method, the component method just underneath here, okay? So I will let you guys to do complete this method, sine cosine rule method for the case B. But we will first discuss, then I will put you back into the breakout rooms, okay? So we briefly discussed that earlier. You can do cosine sine rule only for 2 vector situation because I have to have a triangle to apply cosine sine rule. I cannot apply those rules for anything else. It can be any type of triangle. So I'm going to start with the R12. That is the result from first 2. Then I'm going to draw the third vector starting from here. That's going to be the F3. Remember, when I do that vector, the angle is starting from the positive direction all the way to the, this is going to be R of 1, 2. This angle is actually 114. Now this total angle, which is about 234, okay, which means if I get rid of 180, this total angle should be about 54 degrees, okay, from the negative x direction. We may need that, okay, that's why I just figured out that one. Then this is 114, which means I can find easily this angle, right? This part of the angle, 118 minus 114, 180 minus 114, which is about 71666. Okay, any question, guys? All right, now the resultant is going to be this line, right? Because I have 2 lines now, resultant will be this one. That will be the resultant of vector 1, 2, and 3 because vector 1, 2 resultant already there. I add the third vector. Now I have a triangle. I can use cosine sine rule, right? So which means I can do vector R12 magnitude is equal F3 to the power 2 plus R of 1, 2 to the power 2 minus 2 times F3 R of 1, 2 cosine angle in front of R1, 2, 3. That is actually this part of the angle. We'll say that angle is A. I need to find that, okay? And cosine A is square root of that. Now, what is the angle A? That's important because all of these we know. Only thing which unknown is angle A. I can find that by using just simple geometry. This whole part is 234, this is 54, this is 114, which means this total right here, this whole part is 114. This whole angle is actually 114. So which means I can do this part of the angle A, which should be 114 minus the 54, which is actually 60, right? Yeah, which is 60 degrees. So it's very easy. Angle A is 60 degrees. That's just the geometry, nothing much, just the grade 7, grade 8 level geometry, okay? Now I can calculate the R12, you 1, 2, 3, you have to do that yourself, okay, with your group. And then you have to find the direction of R123, which means the angle is starting from x-axis all the way to here. That's the theta what we needed for this case. I can't find that directly because sine rules allow you to find only something inside. So I can find maybe this angle, this total angle inside the triangle, this part I can find it. Let's consider that is angle B. If I know the B, we can say angle theta, which is equal 114 plus the angle B. Only question is how to get the angle B. I can use the ratios which I used earlier, which means we can write angle B is equal sine inverse parentheses line in front of that angle is actually F3 times the sine of A divided by R of 1, 2, 3. So if 3 is this magnitude we know, angle A we figure out 60, that we know, R1, 2, 3 we already finding here. Then you write the function properly, you will get B, then you add 114, you will get the theta. So that's it. It's very simple, but only problem is that I cannot go by keeping all three vectors. I have to go the result from the two vector first and the third one. Okay, that's the only difference. Then you have to write it down that part and take a picture and then add in to this table right here, case B, method 1. Insert pictures, this device, then you can find the picture usually inside the folder pictures, crop anything unnecessary out, and then nicely reshape this into, resize this into the area which we would like to see. And then you can move it to here, okay? Make sure those are fairly large enough to see, don't put really tiny pictures. I should be able to read the information inside there. Okay, guys, any question? Okay, then let's go back into the breakout rooms. You can finish up the calculation and also discuss amongst you anything. Try to connect with the peers, and then that will be always good, even though we do in the virtual class. One of the reason we do the breakout rooms is also that, okay? Allow you guys to connect with other peers, talk to the other guys, and then discuss anything like the class progress, what you doing to be successful, things like that. Discussing with the peers going to be always very useful. Okay, that's one reason I'm always asking you guys to go to the tutoring center and then talk to the tutor. That's a really good way to get some ideas that really needed in your level. Okay, trying to be isolated and then not to talk anybody, not going to help at all. Then unless you really work hard and or maybe like trying to do anything which is necessary in terms of time-wise to succeed the card, that's okay. But otherwise, I would strongly suggest to talking to the other people always, okay? All right, guys, so let's go back to the breakout rooms.
Professor, can you show me the equation one more time for to get theta?
Yeah, for this next case, right?
Yes.
Yeah, right here.
Okay. And alpha's 60 degrees in there?
A is 60 degrees. Yeah, you can write alpha there. That's okay.
Okay. Thank you.
Yeah. Okay, let's discuss then the component method. Now, the component method, as we move into the next chapter and then so on, this will show up, okay, that we usually call the free body diagram. We will talk about with the next chapter, probably next week. Until that, if I want to work on the component method, all the vectors you should draw like we done in the parallelogram method, which means I should draw the vectors on xy plane, but every vector should start with the origin, from the origin, okay? So which means this is going to be the F1, but I'm working on case A, method 2, and this is going to be theta 1, and then I had another vector here, F2, and then total angle here to here is actually theta 2, which is 160 degrees. That is theta 2. But if I find this angle, it's easy to write the component, right? So this angle is actually just 20 degrees. So then you can write projection, right? We know x-axis, I have a projection F1 cosine theta 1. This direction, I have a projection F2 cosine 20. Then upward direction, I have a projection F1 sine theta 1. I have another projection here F2 sine theta 2. Then if you look this diagram, then you will see two component, vector component, right? If I add everything along y-axis, I will get one y component upward direction. If we add along everything on x-axis, you will get one x component depending on which one is larger. It can be either positive or negative, okay? So I will get one x component, which means resultant from these two I can find by using the Pythagoras, because any of the orthogonal vectors should obey the Pythagoras theorem, okay? And the angle of that r you can write by using the tan inverse of y divided by x. That's it. It's very Simple and very useful in our classwork. Throughout the semester, this method going to show up. And then the only thing you need to find the x resultant, right? Everything you need to add on x-axis. I have positive direction f1 cosine theta 1. Negative direction I have f2 cosine 20. Whatever the larger, that sign will show up. Okay. Then y I have f1 sine theta 1 plus, because everything is on positive direction, f2 sine 20. That's it. Then we find these two, going to put it back into the Pythagoras to find the magnitude, and tan inverse to find the angle theta. That also you have to be careful when we find the angle theta. If the resultant is on second quadrant, you can see this resultant actually on the second quadrant. That theta you're finding may not be from the positive x-axis, may be from the negative x-axis. You have to be a little bit careful, okay? If it is coming from negative x-axis, to get the positive x-axis number, I have to do a little bit of work there. Let's say this is theta prime. Then to find the theta, I can say theta is equal now 180 minus the theta prime, because I'm interested in the angle from positive x direction, right? That's the real theta. But if you do tan inverse by using x negative, y positive, your angle automatically from the negative x-axis, okay? So that's also important. Make sure when you're plugging this, plug right here with the sign, then you will see that negative theta sign also, okay? Then you add 180, then you will get the right angle we needed. That part right here, you need to write and add into that table, okay? Question, guys. We'll bring that screenshot right here. I'm gonna crop out everything unnecessary. Part we don't need. We need only this information, right? That information should go there. That's the method 2, analytical method 2 for the case A. Let's do the function and then see how the numbers gonna work out, okay? Let's do the x by using Excel function. Now you know x is adding all the x component together. I'm going to use parentheses for case by part by part. First part, I need the f1 8.6 multiplied by cosine parentheses radian command angle 35.5 close bracket for radian, close bracket for cosine, close bracket for whole thing. Then minus parentheses f2 11.7 multiplied by cosine parentheses radian. I'm using angle from the negative x direction, that is 20 degrees, close bracket for cosine, close bracket for whole thing. Then hit enter, you will get the x component. That is negative, which means x resultant is on negative direction, right? That's totally fine. Whatever the larger, you will see that sign. So that function I need to include here. Let's put it that here. That's going to be x. We can say x for case A. We don't need to say method 1 or method 2 because we know when we're calculating x, that's going to be on the method 2, right? Component method. And then we'll do y, same way. We don't need this many sig figs. We can get rid of that later. Y component adding all the sine components, parentheses 8.6 multiplied by sine parentheses radians 35.5 close bracket twice close bracket 3 times plus open brackets 11.7 times sine open brackets radians. I'm using angle from negative side, that is 20, close bracket once, twice, 3 times, hit enter. That is the resultant y component upward direction. Okay, this is going to be y. We can say y for case B, case A. All right, now we have components. We can find the result by putting those numbers into the Pythagoras theorem. That's it. It's fairly very simple technique. We'll do the Pythagoras theorem here. SQRT parentheses x to the power 2 plus y to the power 2 cross bracket. I should get exactly the same number as I calculated earlier, 9.842, 9.842. This is analytical result. We don't expect anything to differ at all. Okay. Question, guys. Okay, let's do the R now. You know, R may not be coming directly from the positive side, which means I have to add the 180 to get the right answer. Okay, let's first take a look what is the theta. That's going to be equal. I need the degree command first because Excel do only radian values out. Radian values out and in both. Excel can't read the degrees. Okay. Then arctan, if you type the AT, it will show up ATAN, arctan. Y divided by x. Y is G44 divided by x is G43. Don't put the numbers. Always click on the cell. Close for arctan, close for degrees. Let's take a look at the number. Number is negative 66. That is not the answer what I would like to see. That is correct. That is not wrong. Problem is that actually the resultant is on second quadrant. If I use those x and y, this is actually coming from the negative x direction. So to make it positive, you can add 180 into this answer. If you add 180 at the very end of that function, it will automatically correct into exactly the same answer which I got earlier. Okay. So this will be then theta. All right, guys, question. Okay, seems to be, looks good. Ask any question if you have, okay? Do not hesitate to ask any questions. Okay, so which means you can try to do the next part, which means I have to have a tree vector scenario now. We'll investigate that, then I will put you guys back into breakout rooms. That probably going to be the last time we're going to go into breakout rooms. Make sure you remember or have some sort of contact information of your peers in the breakout rooms. That will be your group members for the lab report. Lab data sheet, everybody has to submit individually. Okay. Now let's take a look case B. For case B, analytical method 2, I have three vector scenario now, which means I need to draw vector diagram, all three vectors including. I have vector 1 here, F1, theta 1. Vector 2 here, F2. Theta 2, I'm not interested. I'm going to use angle 20, that easier. Then vector 3, actually right here, F3, that also angle measured from positive x-axis. That angle is 234 starting from here to here. But it is easier if I can use this part of the angle from negative x direction. That's going to be 54. Okay. Then we'll write it down all the component. The previous component remaining the same. F1 cosine theta 1. I have F2 cosine 20. Then I have another component here now, F3 cosine 54. Upward direction we have two components, F1 sine theta 1, F2 sine 20. Downward direction F3 sine 54. Then it's the same technique. Find the x resultant that I can write F1 cosine theta 1 minus direction I have F2 cosine 20 minus direction I have F3 cosine 54. Then Y F1 sine theta 1 positive direction F2 sine 20, negative direction F3 sine 54. Then we find all of those, then we'll put it into the Pythagoras result again. R is equal x square plus y square root. And then theta is equal tan inverse. That's it. It's exactly same technique. Okay. X square plus y square root. And then theta is tan inverse y over x. Again, you have to be careful how the theta is calculated. This theta gonna be, because this resultant, out of all three, we know where it is. That is on third quadrant. Which is on third quadrant mean definitely this theta not gonna be from positive x. You have to correct that, okay? So remember that. So that's it. Then this written part you included into your table and then do the calculation. We'll go one last time to the breakout rooms. We'll take only a few more minutes there and then we can talk about last table. There's nothing much to do. It's just a simple percentage calculation, okay? All right, guys. Any question, problems?
Sorry, Professor, I was using the bathroom. Have a nice day.
Okay. Continuing to last table. So if you calculated this part, you should get exactly about the same numbers as previous. Make sure when you do theta, you have to correct by adding 180 because the number you're getting actually counterclockwise direction rotation, negative x-axis to downward. So it's a positive angle, but it measured from negative x direction, okay? So when you add 180, you will get the answer from positive x direction. That's the number you needed there, okay? Then make sure this table is completed with your work before you submit, and all the functions, all these graphs, and the table 1. Then we'll do table number 3. That technically nothing much to do. It's just asking you to compare the results you got in table 1 and 2. Because same thing we're calculating again and again by using actually 4 different methods. So we can compare them. Some of them will give you 0 because it's a simulated result. That's okay. So we'll do the calculation. Okay, I will do for case A all of this 6. Then I'm going to add all those functions. Then this case B, all the 6 you can repeat. Okay. Let's do case A. It asking to compare. Carefully read what to comparing. Okay, so the first one right here, we're comparing analytical 1 to analytical 2. That is the numbers in table 2. Okay, all the resultants equal open bracket ABS, open brackets, analytical 1 resultant, table 2 E43 minus analytical 2 resultant, table 2 G45, close brackets, divide by, it's a percentage difference. Denominator should be average, okay, E43 plus G45, close bracket, divide by 2, close double bracket, multiply by 100. And make sure all of these should be in just numbers. If it show up in the scientific notation, never use scientific notation for percentage errors or any errors, okay? Make sure you go into the home menu bar, change that into regular numbers. You can just use the home menu bar in the middle part right here. And if you click the down arrow, then you can change that into just numbers, okay? Take a look. Oops. Because of this front panel, I can't see that. Okay, now it's good. All right, let's change this whole part into just numbers, and then you can see it's 0 because 2 numbers are extremely close. You can keep maybe like 3 or 4 decimals, probably 3 decimals here to make sure all first 3 decimals are 0. But don't keep too many because percentage error values will not going to show more than 2 decimals in general. Okay. All of these also should be in numbers with like 2 or 3 decimals. All of these also should be in numbers, 2 or 3 decimals only. Okay. That function we can include just under the table. We can say PD for R's on case A. Analytical 1 and then analytical 2. Comparing those two, okay. All right, guys, then let's take a look. Theta, I might get the same 0 because it's extremely same answers, close answers, ABC, ABS, open brackets. Theta, resultant theta got from analytical 1, table 2 minus analytical 2, table 2. Close brackets, divide by the average between them, E46 plus G46. Close brackets, close bracket, divide by 2, close double bracket, multiply by 100. Okay, now that also 0. Reason is 2 numbers are extremely closer, down to 4th decimal place, it's exactly the same. It's an analytical calculation, both are calculation method, so we don't expect much differences, okay? That's totally fine, but you need to show that function, okay? Don't just put the 0 there, just calculate that, okay? PD, we can say thetas. Okay, say we are comparing analytical 1 and analytical method number 2. Then you do that for the next case B right here. I will not repeat, you can do that. But we will repeat that for graphical number 1 method, which is tail to head method, to the analytical method 1, that is from first table and the second table. Okay, let's compare that. Resultants, open bracket ABS, open bracket graphical method 1, table 1, cell number E9 minus analytical method 1, cell number E43, close bracket, divide by open double bracket, E9 plus E43, close bracket, divide by 2, close double bracket, multiply by 100. So that shows a number, which means that makes sense because the graphical method, the numbers are rounded into the two significant figures for case A. That's why the error is. Still, it's a rounding error actually. Okay? See, you can see that number when we measuring, the simulator rounded that to the first decimal place. I cannot read anything more in terms of accuracy wise. So that's why that error. So that we can add into the right here the same way. PD is for R's. Case A, I am comparing now graphical method 1 and analytical method 1. Okay, let's do other, it's the same for the theta, open bracket ABS, open another bracket, theta from graphical case 1 minus theta for the analytical method 1, case A, close bracket, divide by open double bracket, the average E10 plus E46, close bracket, divide by 2, close double bracket, multiply by 100. I'm still getting a number, reason the graphical method has a rounding error, that's why, okay? So we'll add that function also here. This is going to be PD for thetas. This is going to be for case A. We are doing graphical 1 and analytical 1. And then you compare graphical 1 to analytical 2 in last column, okay, this one. Same function, equal open bracket ABS, open brackets. Graphical 1 is still R value minus, but analytical, I'm going to use method 2 R value. Method 2 R value right here, G number 45, close brackets. Divide by open double bracket, E9 plus G45, close bracket, divide by 2, close double bracket, multiply by 100. Still, we are getting a number very similar to the previous one because you see analytical 1 and analytical 2 are very similar numbers, right? Only the graphical one has a rounding error. So my percentage error is very similar. And then let's put that function also underneath here. It's a similar function I'm writing because the method is different. I'm comparing different methods, that's why, okay. PD, this is going to be then R's. For case A, I'm comparing graphical 1 and analytical 2 now, okay. It's a different comparison, it's the same function. Then the thetas, open bracket ABS, open bracket, from graphical method 1 theta minus analytical method 2 theta, close bracket, divide by open brackets, E number 10 plus G number 46, divide by 2, close bracket twice, and then multiply by 100. That should be about the same as previous. Then we'll put that also into here. It's going to be then PD, thetas for case A. We are comparing graphical method 1 and analytical method 2. All right, guys. So any question? Okay, so we completed everything. Only thing you have to do, these functions you have to use for case B. All the information you have earlier. Only thing now you have to do, you can do the comparison, but for case B, okay? There's nothing new to do there. we can stop here. Make sure you do that part before you upload the Excel sheet. Okay, anything missing on the Excel sheet, point reduction. Okay. So we'll stop there. If you have any question, always reach out or stay after the class. Otherwise, see you on Thursday. Okay.
Thank you, Professor.